Hey y'all, I'm Sir Pinkbeard and welcome back to the third video in my Learn to Code in .NET 5.6 course. We're going to pick up where we left off in our text-based RPG, and we're going to continue discussing the foundational topics that you need in order to become an expert programmer. Now, if you're just joining at this video, you can click on the card on the screen, which will take you to the playlist, and you can begin from the very beginning of this course. Or you can start and join us right now and try to follow along at your own peril. The choice is yours, but either way, let's get started. We finished off the last video by separating out the main method into two other methods, but that left us with the final step of adjusting the stats for our player still being in the main method, which, if you remember, breaks the single responsibility principle because now the main method is doing more than one thing. We could separate out the stat adjustment, but we couldn't return all of the new stat values by using a single method, and we don't want to write wet code, or code that has logic repeated more than once. So while we could separate this switch case and create a method to adjust each of our stat values, that's going to be a lot more work for us. Instead, let's create an object to hold all of our player data. So, right-click on your Dungeon Adventures project and add in a folder that we'll call Models. This is the standard naming convention for the folder that holds POCO objects, or plain old CLR objects. POCO objects are used to group information together. Inside the new Models folder, let's add in a new class file called Player. When the new file is created, we can see that the player class exists in the Dungeon Adventurers.models namespace. This namespace is where we'll store all of our POCO objects and enums for our RPG. So before we get into the details about what objects are and how they function, let's actually move the D&D class enum that we created previously into the models namespace. Now, if you click and drag the file into the models folder, the D&D class file will be placed in that location. However, you may get a pop-up asking if you really want to move that file. I'd suggest leaving that pop-up active and not checking the box to never prompt again, just in case you accidentally move a file in the future. Now that the file is moved, let's open the file and change the namespace to match the folder structure. With that done, let's move on to objects and what they are. Objects are just a code representation of something in the real world. While there are many different types of objects, objects consist of two things: attributes and behaviors. An attribute is just a variable that is used to define some value about that object, while the behavior is just a task or an action that the object can do. Let's use a pair of wireless headphones as an example. The headphones themselves have a few attributes that we can easily identify. We have the brand name, the current volume, the current battery life, and whether or not the headphones are turned on. There are also behaviors attributed to the headphones, such as increasing or decreasing the volume, toggle on or off, and playing sound. If we were to represent that pair of headphones in a class object, we might get something that looks like this. Up at the top, we have all four of our behaviors: brand name, volume, is on, and power remaining. We also have our four behaviors: increase volume, decrease volume, toggle on off, and play sound. So the headphones class that you can see is a pretty good representation of how you build objects. Just set the attributes and the behaviors, and then you can use that object as you wish in your code. While sometimes you may want to access your attributes directly with public variables, C# actually prefers that you access your attributes using something called properties. A property is a way of exposing an attribute while hiding any implementation or verification code. Properties have three standard keywords associated with them: get, set, and value. The get keyword allows you to return the property's value. The set keyword is used to assign a new value to the property, and the value keyword is the actual value that you're going to set the property to. While the majority of the properties that you work with are going to be read and write, meaning they will have both a get and a set accessor, you can also have a read-only or a write-only property, though the write-only properties are extremely rare and we're not going to talk about them. There are a few different types of properties though, so let's take a minute and talk about those. The first type of property is a property with a backing field. This means that the property has a private variable it uses to store the information. In our example here, our car class has a private variable for speed that is used to actually hold the value of speed. Then the speed property is used to either get the value of the private speed variable or set the value of the private speed variable. If your property has a backing field, the best practice is to make that field private, though it is not technically required. One of the cool things about using properties with backing fields is that you can set some validation logic for what the value of your property can be. For example, if the value that we are trying to set speed to is less than the minimum speed or greater than the maximum speed, we can throw an exception and prevent that value from being set to our private variable. And if neither of those things are true, then we can simply set the value of speed. Next, we have auto properties, which are the variables themselves and do not have a backing field. An auto property doesn't allow you to have any validation, and without a backing field, there's no additional variable that you have to keep track of. So, going back to our car example, our make, model, and color string properties are just accessible and can be used as is. Our final type of property is a read-only property known as an expression body definition. Basically, this property will return some expression as a result. In our example, we can see that if we were to call car info, it would return a string that combines the make, model, and color into a single string. So when you're trying to decide which property type you want to use, here's what you need to consider. If you need something else to occur when the value of that property changes, like validation logic or notifying that a value has changed, you might want to use a property with a backing field. If you're not going to do any validation and the property doesn't need to have a specific value, you can just stick with an auto property. And if you need a property that doesn't need to be set and can just return the same value or an expression based on other information in the class, a body definition property is your best choice. Now that we have a solid understanding of properties, let's go back to our player class and add in some properties for our player. Looking at our main method, we have 6 pieces of data that can all be properly grouped inside our player object. These are name, class choice, attack, defense, magic, and accuracy. We can ignore the error message for now since it's only appearing because we moved the D&D class enum to the dungeonadventure.models workspace. So let's create some auto properties for all 6 of those values. Inside the player class, we can start with the name property. Write public string name, then a set of squiggly braces, and then the get and set accessors. Visual Studio has a shorthand to do this, and we can simply type prop and then tab twice to have Visual Studio create our property for us. And then we can simply change the return type of the property and the name of the property using the tab key to navigate between the 2 highlighted fields. This overall keeps us from having to do a lot of typing. Once we've created our auto properties, we can actually set default values for some of them. So for all 4 of our stat properties, let's set them equal to 5 by adding equals 5 semicolon after the auto property's closing squiggly brace. Then just copy and paste that for the rest of them. At this point, the player object not only has its 6 attributes in the form of our properties, but it also has 4 inherited behaviors. Let's take a quick second and talk about what those inherited behaviors are. Every object you create inherits from a base class called object, and object has 4 behaviors that are passed down to all of the objects that you create. Those are equals, finalize, get hashcode, and toString. And those behaviors can be overridden by the object that you create. You may not need these inherited behaviors, however, if you do, you should override the ones you need to fit your own purposes by using the override keyword. For example, if we wanted to override the inherited toString method that we get from the object base class, we could write public override, and then IntelliSense will give us some options for what we can override. If we choose toString, the method completes and we get return base.toString in the method. Base.toString is C#'s way of saying, let's use the inherited logic for toString. But since the override keyword declares that we're going to use a new implementation for this inherited method, let's change it to fit our needs by returning a string that combines the class type and the player's name. Currently, all of our attributes and behaviors use the public keyword to declare that they are publicly accessible. But now that we're getting into talking about objects, let's take a minute and talk about the different levels of access that we can use. We'll start with the public keyword. The public keyword means that it can be accessed by any other code, either in the same assembly or another assembly. An assembly is just a compiled project. So if a class is public, it can be accessed inside or outside of the project that it is created in, provided the external project knows how to access this particular class. If something is public, it has the most accessibility that it can possibly have. So whether that's a public class, public property, or public method, it can be accessed by basically anything, as long as that thing knows where to find this code. On the opposite side of the spectrum, we have private. Private means that a piece of code can only be accessed by the code inside the same class. So let's say we have a private property called luck. Well, maybe we want to use this internally to determine if something accurate has happened or if there's a critical hit, but we didn't want to expose the luck property to any other class in our code. In that case, we could just declare it as private and it would no longer be accessible outside of the player class. Next on our list is protected. Protected means that a piece of code can only be accessed by code in the same class or in a class that is derived from that class, meaning the additional class inherits from this class. For example, say that we have an internal class called Automobile, and it has two properties, fuel remaining and speed. We also have another class called Truck, which inherits from Automobile, and inheritance here is shown by the colon after the class name. Because Truck inherits from Automobile, Truck can access the fuel remaining property because it is protected. However, the access example class cannot access that property, because that property can only be used by Automobile and classes inheriting from Automobile. So the fuel needed console.writeLine statement cannot access the protected fuel remaining property. Thus, if we want to access whether or not fuel is needed, we have to use the public method contained inside the truck class. Then we have internal, which means that a value can be accessed by any code inside the same assembly, but not in another assembly. In essence, the code can be accessed from inside our Dungeon Adventurers project, but if we create another project like the example code project won't have access to the internal code of Dungeon Adventurers because it is external to that project. And then finally we have protected internal and private protected. Both of these are a combination of their two access levels. Protected internal can be accessed by code in the assembly in which it's declared, or from a derived class in another assembly. And private protected can be accessed by types derived from that class that are declared within its containing assembly. Now you probably won't use these two all that much, but you now understand all of the access modifiers. Now that we have our Poco class object player set up, let's refactor our program to create our player character correctly. To do this, we need to add in a new directory in our project that we're going to call services. Unlike Poco class objects, service objects allow us to do things rather than organize our data. So inside the services folder, create a new class that we're going to call story service. This service is what we're going to use to actually build our character and tell additional pieces of our story. Inside our story service class, let's create two public methods. The first we'll call writeGameIntro. This will be a void method that will simply write out our greeting when the game launches. The second method will return a player object, and we'll call this method createNewPlayer. This gives us a couple of errors. The first is because the story service class doesn't know where to find the player object reference, so we can add in a using statement to attach that. The second is that not all code paths return a value, which we can ignore since we're going to implement both of these methods in just a minute. Now we need to go back to our main method and basically cut out all of that code and put it inside the story service. You can take the welcome adventurer console.writeLine and put that into our writeGameIntro method. Then go back to your program file and add a private static story service variable above our main method. I'll call this variable _storyService because the convention for a class level private variable is that the variable name should start with an underscore. We can then clear out the error message by adding in a using statement from the dropdown. Then inside the main method, call the writeGameIntro method from the story service by writing storyservice.writeGameIntro. Now let's cut out the remaining code in the main method and move it to the createNewPlayer method. Then cut out those two additional methods we created in our program class and move those to the story service class as well. Now that all of the code is in the story service class, let's call the createNewPlayer method from our main method. So under the call to writeGameIntro, let's add varPlayer equals storyService.createNewPlayer. Now we can go back and make the createNewPlayer method actually create and return a player object. Start by adding player equals newPlayer to the top of the createNewPlayer method. This calls the default constructor for the player class to create a new player object. And don't worry, we'll talk more about constructors later in the video. Then we're going to replace all of the individual variable references with the player object equivalent properties. So instead of string name equals createPlayerName, we're going to write player.name equals createPlayerName. Then we also need to adjust the reference to the name variable in our greeting. After that, change the reference from D&D class choice to the player equivalent, and then do the same for the attack, defense, magic, and accuracy properties that we created. After you've replaced all of the individual variables with the player object equivalent, return the player object. Now, to ensure that we keep a single responsibility principle, let's pull out the stat adjustment into its own method. So add a private void method called adjustPlayerStats that has a player parameter. Then simply cut the switch case from the createNewPlayer method and paste it in the adjustPlayerStats method. The final thing we need to do in our story service is change those two additional methods that we have to private regular methods. So we'll remove the static keyword and then replace that with private. Then you can see 3 new dots appear under the method names for createPlayerName, choose_player_class, and adjustPlayerStats. And if I hover over one of them, you'll see that the method does not access instance data and can be marked as static. Now this is just a suggestion from the IDE. You do not have to mark these methods as static, but let's talk about the difference between static and instance data so you can make the best decision. All methods and properties inside a class are either static or instance data, and everything that is not marked with a static keyword is instance data by default. So what does that mean and why is it important? It's important because instance data is duplicated for each new instance of an object. So in our main method right now, we have a single player object and that player has its own name, class, and stats. If we create a second player object, that second player object will have its own instance data for those same properties. Now, if we do that, we can see that it's currently giving us an error, so let's add in the using statement so the main method knows what a player object is. Because the players have their own instance data, we can change that data and the object will not be affected. I'll show you what I mean by commenting this out and creating 2 new player objects. The first player object I'll create is a wizard named Bob. The second player object will call Thomas and make them a fighter. And then I'll add in 2 write-line statements where I print out player 1 and player 2. Now inside the interpolation brackets, I can just put the object variable name, and the 2 string methods for those objects will automatically be called. In fact, if I add the 2 string method call explicitly, we can see that the interpolation can be simplified by removing that 2 string call. So now, if I run this application, you'll see that player 1 prints out wizard and then Bob, and player 2 prints out fighter and then Thomas, because each object has its own instance of the name and fighter properties. Static properties and methods, on the other hand, are shared between all instances of the class object. So real quick, let's add in a new public static string property called race to the player class. This property will be shared between all instances of the player class object. Let's also adjust the 2 string method to now account for this new property. Now we'll go back to the main method and set player 1's race property to human. When I do that, you can see an error message appear. The reason is that static properties cannot be accessed through an instance of the class. Instead, you have to access it directly from the class level. So instead of player1.race, I need to write player.race. Now because this property is static, both instances of the player class will share the same race value. So even if I change the player's race after I create the second instance of player class, the player race will still be the same between both objects. So that's the difference between static and instance data. Static data is shared between all instances of the class type, and instance data is duplicated for each new object. Let me undo those changes by deleting the code I added and then uncommenting the existing code by using that button up at the top. For the next part of our game, we want the story service to give us a small cutscene using our player character, and then we'll go into the actual dungeon cave adventuring that this RPG is focused on. So underneath where we create our player, let's add a story service.guildInitiation method call, and let's pass in the player object as an argument. Now obviously that method does not yet exist. So if we hover over that error message, we get a dropdown with an option to generate that method for us. So choose that option and then have Visual Studio create the method for us in our story service class, and then go check out that new method in that story service class. We can see that the new method is generated as an internal void method, which is great because this method needs to be accessed in another part of the project, and it's not going to return anything. We can also see that it properly accepts the player parameter that we passed into it. And now all we need to do is remove the throw new not implemented exception and add some code to this method. Now that we're passing objects as arguments to methods, it's time to talk about an advanced method topic called pass-by-value and pass-by-reference. How they differ is extremely important as we get into more complicated programs because you want to be able to understand how your data is being interacted with so that you can know what is possible and what can change when the data is in that other method. To fully understand this, you need to know the difference between value types, which include but are not limited to primitive data types, and reference types, which consist of all objects. A variable of a value type, like int x, contains an instance of that type, and directly holds a value. However, a variable of a reference type, like our player object, holds only a reference to the memory location where that data is stored. So here's how this plays out. When I create two int variables, int x and int y, and I set them to some value, I get two different variables, each containing its own data. If I then set the value of y to x, y would hold a copy of the value of x and not the original data. However, if I were to do the same thing with two player objects and I set player 2 equal to player 1, player 2 does not contain a copy of player 1. Instead, the player 2 variable now references the same data as player 1 variable, and the original data referenced by the player 2 variable can no longer be accessed. Since they both reference the same data in memory, I can change the properties of the referenced data using either variable, and the data will update. So how does this information transfer to passing arguments? Well, when you pass any of the value types, they pass by value, meaning that a copy of the data they contain is sent to the method and then assigned to the parameter that accepts the argument. For example, in the PBV example method, we have an int x equals 7, and then we call pass-by-value and pass x as an argument. The value of x is sent to the pass-by-value method, and so inside the pass-by-value method, x starts as 7. Then we add 3 to x, and then we print out x. When we do that, 10 is printed to the console. However, when the flow of control returns to the PBV example method, the console.writeLine statement prints 7. That's because primitive data types pass by value and not by reference. While primitive data types pass by value, by default all objects pass by reference, meaning that the reference to the data in memory is sent to the method as an argument. And whatever changes you make to that data inside the method will persist when the flow of control returns. That said, C# also has a way to pass primitive data types by reference by using the ref keyword. Our example code here is basically the same as the pass-by-value example, with the exception that we are using the ref keyword. Now, when we use that ref keyword, we don't pass a copy of the data. Instead, the ref keyword passes a reference to that data in memory. This allows any changes to the variable inside the method to persist just like how objects do. So then, inside of the pass-by-reference method, when we add 4 to the value of x, the value in memory actually increases by 4. While this is something you can do and there are definitely uses for it, it's less common to use this keyword. If you find yourself having to pass many primitive data types with the ref keyword, perhaps it would be better to build up an object and group all of that data together. When passing by reference, you need to be careful that you don't overwrite the object reference unintentionally. For example, in my guild initiation method, if I wrote player equals new player, what I've done is change the reference location for this variable. So any changes that I make inside this method will not affect the data that I passed in as a reference, but rather those changes will be applied to a new set of data that won't exist when this method is finished. Since I'm immediately overriding the initial value of the player parameter, Visual Studio actually offers the suggestion that the player parameter should be removed since the initial value isn't being used. Understanding that objects work by references and not by values is super important if you ever have to compare two objects. It's why the base class object has the inherited method .equals, because you can only guarantee that two objects are equal if they use that method and you provide particular criteria to determine equality, or if they point to the exact same memory location. So with the exception of strings, don't try to use the double equal sign to determine if two objects are equal to each other, because you likely won't get the answer you're looking for. Anyway, that's enough about pass by reference and value. Let's go back to the method and finish it out. Now, the point of the guild initiation method is to be a small cutscene before we throw our character into the dungeon. So it's mostly going to be a bunch of console.write statements telling a story to our player. Now, you can adjust the story and the text however you want, which is why this is a time lapse and I'm not telling you exactly what to write. However, I will make a recommendation that you create a wait for the reader method like I do. It's incredibly important because we want the reader to be able to read at a pace that is comfortable for them. We don't want to give them a wall of text, and that's usually why you get 2 or maybe 3 lines of text when you're playing any other video game. 2 to 3 lines is just enough text to read and digest and understand, and then you can move on when you're ready. Because this is a console game, be sure to give your player some type of interaction when you're giving them a cutscene like this so that they can feel more engaged with it. There's no fancy UI to show them what's going on, so this is really what we have to do to get them to engage with the game. Finally, at the end of this method, I want to give my player 2 potions that they may need during the initiation combat that I'm going to have them go through. However, in order to give them the potions, we will need to create some new objects. Let's start by creating a new item class in our model's namespace. Inside that item class, let's add 2 string properties called name and description. This will be the base class for all of the items that we create in our game. Since all objects inherit from the object base class, this will provide another level of inheritance to ensure that all of our items have the name and description attributes. Next, let's create a class called potion and have it inherit from the item class. Inside our potion class, we want to add 2 properties. The first will be a potion type enum property called type, and we'll create an enum for that in a second, so just leave it as is for now. And the second property will be an int called effect amount. We also want to add a public void method called apply effect that takes in a player object as a parameter. Now up to this point, when we've created an object like our player object, we've accessed the properties directly and set them after we've created the object. In doing so, we made use of the default constructor for that object. The default constructor allows us to build a new instance of that object's class without providing any starting information. Default constructors are only available to an object if the player has no custom constructors or if it is explicitly written in the class. Now we can add in the default constructor by simply typing ctor and tab twice. By default, constructors take in no parameters. However, we actually can create a custom constructor where objects must be created with some required information. For example, I don't want myself or anyone else to be able to create potions in this project without having an assigned type and an effect amount for that potion. To ensure that I can't create a blank potion or a potion without that information, I need to add some parameters to my default constructor. Since we want to define the type of potion and the effect amount, I'll add in 2 parameters. The first will be the potion type parameter, and the second will be an int effect amount parameter. Then we'll set the properties to the value of the parameter, and we'll be good to go. So type equals type, and effect amount equals effect amount. This sets our properties to the values received in the constructor. Now let's adjust the properties so that the get accessor is public like the property, but the set accessor is private. This way, the value of these properties can only be set somewhere inside this class, meaning we can't accidentally change the value or the amount of the potion from somewhere else in the code. Now we've got a couple of errors because potion type doesn't exist, so let's add in an internal enum called potion type. While you can create a bunch of different types of potions if you want to, I'm going to keep things simple and I'm only going to create 2 types, health and mana. Back in our potions class, we can see the potion type enum is now recognized, and it's time for us to set the name and description for the potion based on the type. To make potion inherit from item, add a colon after the class name and type item. Now in the constructor, we can set the name and description by creating a method called setNameAndDescription. Have Visual Studio create the method, and then let's add in our name logic. Add an if statement to check for the potion type, and then add in a name and description. Since I'm only using 2 types of potions, I can simply use an else statement to set the other value. Now that that's finished, we can apply the potion's effect to the player. To apply our item's effect to the player object, let's just add in a quick if-else chain where we check if the type is equal to either health or mana, and then adjust the player's health or magic appropriately by using the compound addition operator. Now if we try that, you'll see that player.health doesn't actually exist. So what we need to do here is add in a new attribute for our player. Let's head over to our player class and add in some properties with backing fields. To add this in quickly, we can type prop full and then hit tab twice, and Visual Studio will create the backing field and the property for us. Then we can simply tab through the highlighted sections and adjust the name and type of our property and backing field. We'll do this a couple of times, but let's start with health. Once we add in health, let's add in another one called max health, and I'm going to set the max health private backing field to 20. This way, the get will simply return the max health, and then we'll have a private set accessor for changing the max health value so that the value of the maximum health cannot change throughout the game except for in the player class, maybe if we wanted to add in a leveling up system or something like that. Now inside the health property, we need to do a little validation. So let's add an if statement here that checks whether or not health plus value is greater than max health. If it is, we need to set health equal to the maximum health. And if it's not, we'll just add the value to the health. And while we're here, we may as well go ahead and do the exact same thing for max mana and mana, because we'll be adding magic with our potions. Now that we've added in all that we need to in order to create our potions, we can go back over to the story service class and create new potion objects using the non-default constructor. I'm going to go ahead and make one of them a health potion and the other one a mana potion, but you can add what you'd like. So we've created potions, and we've said in our console.writeline that the player will receive 2 potions. But how do we actually give the potions that we've created to our player character? Well, there are a couple of different ways we could go. The first is the easy one. We could add 2 potion properties to our player character and set each of those properties to one of the potions. However, that limits our character to only ever holding 2 potions, and maybe we want to have them hold other items, like the key that we've got to search for. So simply adding 2 potions or even item properties to our player character is not the solution we're looking for. Instead, we need to look at something called collections. However, this video is getting quite long, so let's hold off until the next one where we'll take a complete look at collections and the last 2 things that we need to talk about to finish your foundation of programming knowledge, and we'll finish out the game. Alright y'all, thanks for watching to this point in the video, and well done for making it here. If you followed along, you have learned and digested a ton of information that is foundational for you to become a software developer. If you're enjoying the video series, consider a like, let me know in the comments, or subscribe if you want to be present when I create more tutorials like this in the future. Alright guys, I'm Sir Pinkbeard, thanks for watching, and I'll see you guys in the next one.